Let's deal with some more complex issues like work, conservation of energy, friction. Okay, so we'll do an example here. If a, I don't know, car rolls down a hill what is the final velocity? Let's do that for example. Let's do a simple one and then we'll add some friction into it. So let's make that a 4-meter hill. Let's make the car mass equals 1200 kg. So if we draw a picture, we have a hill, we have a car, weighs 1200 kg. Okay, what is its final velocity if it started at 2 meters per second? Okay, so let's make this a little harder. So we've got a couple of people, they give the car a push, or either going to like jump start it or something like this. They got the car up to 2 meters per second and then it goes down a hill, 4 meter tall hill. So what we have to do is conservation of energy. Remember, conservation of energy says the total energy at the beginning equals the total energy at the end. So let's work out the initial energy. Energy initial is going to equal EK, because the car's rolling, plus EP, the potential energy at the top. So EK, the initial, equals half mv squared, which equals half mass, which is 1200 kg, times velocity, 2 meters per second, squared, equals, what's that, 1200 times 2 squared times 0.5 equals 2,400 joules. So it's got 2,400 joules of rolling energy, of kinetic energy. E initial, E potential equals mgh, which is equal to 1200 kg. We're going to use 10 meters per second squared for gravity, times 4 meters equals 1200 times 10 times 4 equals 48,000. Didn't even need a calculator for that. 48,000 joules of energy. So the total sum of initial energy is going to equal 48,000 plus 2,000, so 50,400 joules of energy. So this is before. So the final energy is going to equal the same as the initial energy. So the final energy is going to equal 50,400 joules. But now all of that energy at the bottom is going to be kinetic after. So E final equals EP, pardon, plus EK at the bottom, that's going to equal 0, plus half mv squared. Well, plus, yeah. So plus EK. So EK, to work out the velocity, EK equals half mv squared. Rearrange that like we did before, so V is equal to 2 EK over M equals square root of 2 times 50,400 joules over the mass was 1200 kgs equals whoops, sorry, 100 divided by 1200. If you take the root of the answer equals 9.165 meters per second. That's assuming there's no friction or anything. Okay, so what if there is friction? And we'll do that in the next example. We'll do that. We'll use exactly the same thing, but we'll put in a friction force.